MTTR, mean time to repair. Another classical measure, this indicates how long it takes for services that are impacted by failures to be restored. Of course, for all these metrics, a question needs to be asked. Availability, MTBF, MTTR, of what? The metrics can be applied to individual services in a network and to the service as a whole. However, it is quite clear what counts from the perspective of the customer. That customer service, it is important to realize that availability of a service and of a device in the network that carries the service are not the same. The good news is that service availability can be much higher than availability of the network or network devices. For example, when a device fails, services might automatically be switched over to other services in the network. Nevertheless, it is also availability of the network equipment could ultimately affect services as well. In addition, it leads to negative impacts on operational costs because failures must be dealt with it. As with many of the other metrics, it often makes sense to further differentiate these metrics and distinguish between different types of devices, different types of services, different technological regions, and different domains of responsibility between organizational subgroups. This can be your data for interesting comparative evaluations. For example, if one of the group in the organization consistently scores higher on certain management metrics, it might be possible to learn important lessons from that group and apply them to the other parts of the organization. Finally, in the eyes of the customer, maintenance is another factor that impacts availability. Needing to account for maintenance operation is an inconvenience, although of course, it is by far preferable to unexpected services outages. One meaningful metric with regard to the effectiveness of the maintenance is the ratio between unplanned outages and scheduled maintenance intervals for services and for managed devices. Clearly, this ratio should be as close to zero as possible. Another metric is mean time to maintenance. Although the ratio between unplanned outages and scheduled maintenance intervals might be improved simply by increasing the number of the maintenance intervals, doing so would come to the expense of this metric. In addition to being a factor in availability, how often maintenance needs to be performed is a factor. Management metrics to track contribution to management effectiveness. Metrics that can be used to assess management business impact are one way to assess management effectiveness. However, those metrics do not tell the entire story. Many factors impact management effectiveness, each of which is the result of the combination of the features. For example, some features of management application make networks managers more productive. Other features improve operational robustness by making it harder for network managers to introduce inconsistent configurations. The operational equipment of shooting themselves in the fleet. An important question, therefore, concerns whether it is possible to assess the individual contribution of each of those features to management effectiveness. Although the metrics that have so far been discussed allows assessment of the impact that management features collectively have, they provide no indication of their individual effectiveness. In some cases, it is possible to do better. It is the topic of the following discussion. Metrics for complexity of operational tasks. Perhaps the most important aspect of the contributes to management effectiveness concerns the complexity of the operational tasks that the network managers are faced with. Reducing complexity is important for a number of reasons. It reduces operational costs because the operators generally have fewer steps to perform a given task, and those steps may be simpler, requiring less training. It allows the completion of more the same task in the same time, thereby increasing operational true output. It reduces the opportunity to introduce errors, which might impact availability and demand complicated recovery. The management metrics that we have encountered far allow us to see the impact of complexity on business. However, they do not allow us to assess complexity directly. Complexity of operational tasks can be assessed in a number of ways, many of which were first articulated in a paper by Brown, Keller, and Hellerstein that was published at the IM 2005 conference. This conference is listed in Appendix B for the reading. Three different categories of complexity are distinguished. Execution complexity consists of two aspects: the number of steps that the task involves, the number of context switches involved in a task. Roughly, this reflects how many different targets, for example, different pieces of networking equipment or different types of device interfaces, the steps are directed at. Parameter complexity concerns the complexity of the parameters that are required as part of each step. This complexity is determined by several aspects, including the following: the number of the different parameters that are required for all steps in total, the average number of parameters that are required in steps. Some parameters are required in more than one step. The ease which a network manager can obtain these parameters value for each parameter, a corresponding score is assigned. A high score is applied when a parameter represents an obscure value that requires a good deal of experience to choose. A low score is applied for parameters that are obvious, or that required only a simple lookup. Scores for all parameters are aggregated. Memory complexity concerns the amount of the memory that is required in the mind of the network manager to perform the steps. It takes into account the number of the parameters that must be remembered, the length of the time they must be retained in the memory, and how many intervening times were stored in the memory between uses of the remembered parameters. Memory complexity can be expressed with a large depth of stack that would be required to hold the required items. To obtain management metrics from those complexity measures, a number of benchmarks that should be selected for which complexity is assessed according to the mentioned criteria. For example, tasks such as the following are good candidates: adding a device to the network in the rudimentary configuration, adding a device to the network in advanced configuration such as redundant failover configuration, configuring all interfaces of the device with the same of the parameters. For example, this could be configuring all DSO ports, online cards for voice service with a certain interpolation setting. Configuration a loopback on an interface. Configuring an IPsec tunnel for an interface network topology. Adding a subscribe to a service. Clearly, it is possible for the different management applications to score quite differently when their duration of complexity is evaluated against the benchmarks. For example, consider the operational complexity that is involved in adding a subscribe to a service. An operation support environment that includes an application that offers cookie-cutter templates to facilitate this task will achieve a much better score than the operation support environment, which is a very aspect the device has to be configured individually, because more steps would need to be performed and more parameters would have to be remembered. Of course, we expected this outcome, but it is nice to have it backed up by quantifiable data. Related to metrics that intend to capture operational complexity for network managers are metrics that attempt to capture operational complexity for management applications. Instead of the number of the complexity of the individual operation steps, key indicators or number of complexity of the communication exchange that need to take place. As before, it is advisable to select a number of benchmark tasks that are representative for task management application phase. Here are some examples. Keeping an application synchronized with the actual device configuration would mean the time between configuration changes 48 hours and maximum permissible time lag to reflect a change in configuration at 15 minutes. Collecting a set of performance counters periodically every 15 minutes over an interval of 24 hours. Running a diagnostic test pattern every 15 minutes over the period of 24 hours and being notified when an abnormal result occurs. Subsequently, the complexity of the changes between a managed network and a managed application is assessed. The number of communication exchanges that are required. The number of the dependencies between those exchanges, measured by the number of exchanges that need to be serialized as one of the exchange relies on a piece of the information provided by another. This also indicates the complexity of the rainy day scenarios in which things goes wrong and need to be recovered from. Again, different capabilities of the system agents will yield vastly different results. For example, those results show that to keep a management application synchronized with a managed device, a much lower number of communication exchanges is required when a reliable configuration exchange events are supported, compared to cases in which periodic sync up with devices is required.